Number 11. Which of the following equations is the most appropriate linear model for the data shown in the scatter plot? They love putting in scatter plots into the SAT. This is, I think, a little unusual that it calls it the most appropriate linear model. Usually they refer to it as the line of best fit because that is what it's called in statistics, the line of best fit. And it's referring to a line that when you draw it through a bunch of dots, that's what a scatter plot is, it's dots showing data. When you draw that line through those dots, it is the line that has the smallest average distance from each point. So it's like the closest you can get to all the lines. Now on the SAT, currently, they do not ever ask you to, on your own, calculate a line of best fit. So you don't have to know how to do that. What they are going to do, so they're not going to give you like a bunch of, these, they're not going to take these dots and put them in a table of XY values and say, calculate the line of best fit. They don't do that. What they do, and this is an easier version, so it's good for you, is they give you a graph of dots and they say, what would be the equation of a line that would go through that? And it's not going to be subtle. It's not going to be like one says y equals negative 1.8x and one says y equals negative 1.9x, and you have to determine which of those is the better line of best fit. Not even a little bit. It's going to be very broad strokes. It will be either a positive or negative slope, and then either a positive or negative y-intercept. If you can identify, if I draw a line like this, is that a positive or negative slope, and does it have a positive or negative y-intercept? And it won't be close. It will be very distinct. And that's what we have going on here. See, as you can see, we have two answers that have a negative slope, two answers that have a positive slope. All the numbers, 1.9, 1.9, it's all the same. And for the y-intercepts, we have two that have negative slopes, and I have two that have negative y-intercepts and two that have positive y-intercepts. So that's all we have to determine. All the numbers are the same. And just as a review, in case you missed the previous question, y equals mx plus b, that's our slope intercept form. M, the number by the x, is our slope. B, the number that's by itself, that is our y-intercept. Okay, so slope being positive or negative. Think of it as how you read. If you're going left to right, in English we read from left to right. So if you're going up as you read, you're going up towards the future. The future is bright. It's positive. We're going up towards the positive y. It is a positive slope. If, as we go left to right, we're going down. Oh, I'm going down. I'm feeling down. It's negative. I've got negative feelings. I'm feeling down. I'm going down. You are going towards the negative y. That's a negative slope. If you are questioning yourself on the day, you can always pick a couple of points and do a test. So if I draw this line, then I might say, okay, 2 points that are on the line, that looks like it's kind of on the line, and that looks like it's kind of on the line. I'll take those 2 points. It's rise over run, like how far it goes up or down, over how far it goes left or right. So it's going down 2. So the rise, it's a negative rise, it's going down 2, and it's going to the right about 1. So negative 2 over 1, that is negative 2. You can also, the equation you'll also see in your math class is y2 minus y1 over x2 minus x1. It's where you pick those points and plug them in. So this first point would be 3, 5, and the second point is 4, 3. On my little approximate line, I can plug those in, and I would get 5 minus 3 from there over 3 minus 4, and that gives me a positive 2 on the top and a negative 1 on the bottom. Again, I get negative 2. So any of these ways, either just looking at it or counting it on the graph or doing the slope formula, they're all fine, whatever works best for you. So all 3 ways concur. This is a negative slope. As we go left to right, it is going down. That's a negative slope. So that eliminates C and D, because they have positive slopes for that number that's by the x. Now we just need to look at the y-intercept. Is that a negative or positive? Well, we're going 0 and then we're going up. This is the positive y. Down here below 0 would be the negative y. It's going to be intercepting up here near positive 10. So that is a positive y-intercept. So B, with a negative slope and a positive y-intercept, that's my answer. So yeah, don't get too worried about the ones that are lines of best fit. Again, you will not have to calculate it from scratch by looking at a table of data. They're dressing it up by saying it's a scatter plot and what's the linear model and the line of best fit. And it really just is, hey, you know how this kind of looks like a line? Does that line have a positive or negative slope? And does it have a positive or negative y-intercept? That's all they're asking. If you got that, you're good. Hey guys, the full insanely comprehensive SAT math prep course I've been promising for so long is live right now at mathwithalyssa.com. And of course, you can also still get the free 10 video course on SAT tips and tricks at mathwithalyssa.com as well. You also can now book one-on-one tutoring sessions with me. Links to how you can do that are in the description and the pinned comment below. And as always, if the video you just watched was helpful or useful in any way, please let YouTube know. Comment, like, share, subscribe. You know the drill. Thank you so much for watching. Hope you have a great day. See you later. Bye.